So today we are going to complete our introduction to machine learning, and this is a part two of the session. So before we get into what can ML do, we have to talk about what we have done yesterday, and we have to recap them. So some of the key points that we Sneha have discussed yesterday's session was what was ML and Google Crowdsource Smart Camera and Google Quick Draw and some of the differences between rule-based and machine learning and some concepts related to machine learning process and idea to implementation. And today's session we will get into in depth into machine learning and some of the different types of machine learning involved in it and different types of keywords that are used to talk about specific algorithms. So as you can see, we hear a lot of these words: artificial intelligence, machine learning, and deep learning in nowadays. So a lot of people don't know the differences between these three words, and there are key differences between these. So artificial intelligence is a domain which tries to mimic human intelligence. It can be a rule-based approach or even machine learning. So it spans about all the applications that try to mimic human intelligence, like smart appliances and stuff. So that artificial intelligence lies in that domain. And if you see machine learning is more into in creating models to specific task and trying to solve a specific task using a particular algorithm. So that is machine learning. And deep learning is a type of machine learning inside machine learning which tries to have different types of machine learning models, like in a linear fashion and layer fashion, in order to create and solve even more complicated problems. So like solving and understanding images, and whereas machine learning tries to solve more of textual data and simple tasks. So these are the differences between these three words. Now let's get into big data, algorithms, and technologies. These three key important things made what ML we see nowadays. So ML algorithms were available even a century back, but because of computational power, we weren't able to run any of these algorithms a century back. And as we have seen last few decades, we were generating a large amount of data. But one of the big issues with big data was it wasn't clean data. So because of that, we weren't able to achieve the necessary applications of machine learning. Because of this, there was a incident called AI winter. So it is a phase where people were losing interest in machine learning because they were having a lot of data, but they weren't able to make use of any of the applications on it. So this is our current situation. Because of improvement in technology and compute power, we were able to generate very good machine learning models which can be used in real time and real world applications. So collection of all these three important revolutions in our history, we were able to pull and get machine learning into real world and trying to solve real applications. Now let's get into different types inside machine learning. So first type that we normally hear is classification models. So classification models basically tries to classify. So you can think of it as you have limited number of classes, and the model tends to classify that into a particular class. So here classes mean, like, if you have a mail, so if in your mail there is something called spam detection, in order to reduce fraudulent mails. So so machine learning is involved there in order to classify the mails into two different domains, like spam and not ham. So if you see in this 2D plot, you can see these are the mails which are fraudulent and these are the mails which are safe to open. So machine learning model has algorithms in order to classify which is spam and which is not ham. And these classification models give you the confidence level and this confidence level can be used to sort out the final results. And for another example, you can see here the image here has, it can predict three different classes. One is lion, and as the image is lion, and if you see the other background of it is wildlife where the lion is present. So machine learning model can classify these kind of classes out of a particular image. So classification is equals to classes, and that's how we should remember it. So now to see it real time implementation of this particular model, you can actually go to crowdsource application that you have recently installed, and open sentiment evaluation or image label verification or smart camera. In any of these three, you can see the application of this particular classification algorithm being applied. And so when you open the application, you will find these three options inside the crowdsource. And sentiment evaluation tries to solve and find the sentiment of a particular uh, given text or image. And image label verification is used to verify a particular image is a has a proper label to it. And smart camera is to detect commonly used objects using camera. Okay, so the next machine learning type that we would be looking is regression. And I think this particular algorithm, I think you would have faced every day. So when you look into Google Maps or anything, when you search for two different points, and if you search for uh, potential potentially very fast route or good route, and you find a route which is mapped by Google. So this is one of the good examples of regression. This is more of trying to solve a range issue. So if you nowadays you see a lot of news regarding stocks. So for stock prediction, like the number to be predicted, we use regression. As you can see, this is a 2D plot where the you can take it as an example of a data of or the points of previous stock prices or something related to that, and you can predict the upcoming price of the stock based on this regression model. So this regression will solve more of a range issue, and classification solves classes issue. Yes. So the next type of algorithm is clustering. So this is more of a clustering algorithm, or where the label of the data is not given. So for when you see classification models, the mails that you have a label called spam or ham, but a lot of data in this real world doesn't have labels. So if you see here alphabets, handwritten alphabets, you don't have the labels. But if you use clustering algorithms try to give you closest all the closest letters. As you can see here, all the twos are arranged here and all the sevens are arranged here. So this is done based on finding the similarity between the structure of these images. So here 7 and 2 looks almost similar. So that is why they are placed nearby. And when you see other letters, they are pretty far from these particular letters. So it's basically clustering different objects or different uh, texts or something based on the inner meaning of that particular image or the text. So that is how the clustering works. So you can find out and implement or use clustering algorithms in semantic similarity module in crowdsource application. Yes. So after semantic similarity, we'll get into a new algorithm called sequence prediction. So nowadays we use a lot of Google keyboard where you swipe and all the text or the words are predicted based on how you scribble in the keyboard, and this is done by sequence prediction. So based on the sequence of letters that you try to scribble, it finds out the words for that particular type. So this is more of predicting future or the particular word based on the sequence of letters or sequence of path that you have taken. So, and you can try this particular sequence prediction model inside glide type or handwriting recognition or translation module in crowdsource application. And if you don't have mobile application, you can even check out the crowdsource.app on the web, and you can try these things online too. So okay, so let's get into the new application of machine learning, or the type of machine learning. This type is the fifth, and it is called style transfer. So this is a generative model. So it tries to generate new style based on combination of two different inputs. Like you can see here, the image that needs to get style getting transformed is tortoise, and the template that you're giving for the style that needs to get applied is is a wave. And you can see the output where the tortoise is getting kind of a painting style transformation. So this is an image based application of style transfer, and you can even see here. So there are two different voices, and this particular application is to create new voice based on two different voices. So it's like you have a text in one particular language, particular voice, like here male voice, and you're trying to combine that with female voice in order to create completely new voice in order to it for our specifications. Like here trying to generate male out of combining male and female voices. So this particular type of machine learning model is called style transfer, and we use style transfer in a lot of applications, like filters in Instagram and other places wherever we are trying to change the look of an image or voice in order to make it uh, better.
I have a doubt here.
Okay, go on, Abhog.
This one, you told about this picture about the painting and the voices, right? I
Yes,
mean,
yes.
the both mean that style transfer. It doesn't mean that both should be in one app or one website or something. I mean, is it separate topic that we are talking about, or is it combined topic with a different
Yeah,
knowledge?
so like the basic idea of transforming a particular type of data to another type is style transfer. So here we are discussing about just images and audio files, but this style transfer can be used for different things, like creating totally different people out of the data, like the given data. Like you can create not just tortoise or like waves, you can create different art based on these particular models. So in industry they use term called GANs, generative adversarial networks. So these GANs are used in order to produce fake people or deep fakes. So that is how you get deep fakes and stuff. So did it answer your doubt, Among?
Yeah, yeah, yeah. Got it.
Yeah,
Thank you so
yeah.
much.
So if it's clear, probably I'll go to the questionnaire, and if you face any kind of problem or why the answer for the questionnaire is particular option, you can discuss with us, and probably we can give you more clarity about it. So now we'll start with questionnaire. So we are going to find out what type of machine learning is being applied to a particular situation. Okay, so we have five options here that I have discussed earlier. Now let's look into how this particular situation is being applied, like what kind of algorithm is being applied. Few situations you can use multiple types also. So uh, try to don't get confused if particular implementation can be used like multiple algorithms.
Is it
So here,
clustering?
okay, so clustering. So the situation is recommending next word in the Android SMS app based on the word typed so far. So the first option that was told was clustering. So anybody have different answers. And before telling the option,
Sequence
can you?
prediction.
Oh, okay. Sequence prediction and clustering, we got options. So, any more options?
Classification.
Classification. Okay. So, right now we got classification, clustering, and sequence prediction. So, anybody can answer the reason behind these options. I'll give you the final answer afterwards. So, we can.
Well, I said classification because in while recommending the next word in an SMS, because we could just classify it based on what the message is about. Like if the message is about some bank or something, that can predict the word from words used in normally bank SMS and all those stuff. So we basically
Okay.
classify those words and then
Hmm.
we recommend the user to type it there.
Okay. Okay. We'll get to the answer in few more seconds. And anybody wants to give reason for other options, it might be like clustering or sequence prediction. The reason behind it, probably.
I said sequence prediction because it would normally record the sequence of messages or symbols that
Hmm.
is usually used after a particular word.
Okay. Yeah. So, anyone about clustering? So I think we can move ahead with the answer, I guess. So the answer is sequence prediction, and it was exactly correct what she has mentioned. So we use sequence prediction in order to find the next word. So it cannot just like in the example we have used a keyboard where you're drawing on a keyboard, or like you're scribbling on a keyboard and trying to get a word. So in this particular scenario, we are, instead of letters, we are having words. So sequence of words will predict the next word. So my name is will predict the new, like if you just type my name, and this particular application will predict the new word is. So we'll try to fill the next word. So that is sequence prediction. And we have more questions. So the next question is labeling email as spam or not spam. Yeah. Any guesses? I think it's pretty easy. That's any algorithm that you think of will suit this particular problem. Any guess? Like no problem, even if you make a mistake. So uh,
Classification.
okay. So yeah. So this particular scenario, we use classification uh, because here we have these two things like spam and not spam are called classes. So wherever you see classes, majority of the times you will be using classification. So the next question: identifying trends amongst a group of people who have brought a new music release. So any idea about which algorithm is used? It can be wrong, so no problem. We can correct it and get a clear understanding. So try to have a guess and give
Clustering,
us.
maybe.
Is it
Okay.
clustering?
Yes, it is clustering. And do you do like anyone wants to give an explanation for it? Clustering? Why it is clustering? Okay, no problem. Probably, yeah. So it is clustering because in music you can see different kinds of genres and different types of music. So in new music releases, probably the genre is aligned with some other genre. So that's where you get to use the clustering algorithms. So in order to predict the similarity between other music and try to map it and find the good place of that particular music. So that is clustering. So in this particular example, so like clusters or trends or groupings, so these are the factors that depend in this particular type. So next question: a bot that reads the news in the voices of famous actors. So I think
Style transfer.
okay, yeah. So any, can you give the reason for it? Why why it is style transfer?
Because In many if you record a famous actor's voice and you feed it to a robot or something, it tries to uh, do the same voice. I mean, produce the same kind of voice that the actors do
Yeah.
and the way they speak to. So, think that style transfer works.
Yes, that's correct. So we try to use the language that we want our voice to get transferred to, and for this particular type, we'll be using style transfer. So next example, determining what workout activity based on phone movement. Determining different workout activities means you have a less number of options. So any algorithm that deals with number of activities. Any guess?
Classification.
Yes. So the option is classification. Can you tell why? Answer is classification. You're correct. So why do you think classification? Okay, so no problem. So here we like when you think about workout activities, you have jogging, running, or different kinds of exercises, right? So you have limited number of exercises, not in a range of exercises. So that is why we are using classification. So yeah, that is why we have identifying famous landmarks in a photo.
Sequence prediction.
Okay, any other option, any other type of algorithm that can be used? Okay, so the answer for this is classification. It is classification because the famous landmarks you have a few, and so if it is any other algorithm, uh, it won't be classifying something. So other algorithms like sequence prediction or something, it's based on the past data, like based on what was the data given, like in a particular sentence you have a sequence of words, so it'll be able to predict that particular, like related to that sequence of words. And when it is style transfer, it is trying to transfer the style. So in this particular scenario, we are trying to identify a particular object or a particular thing from a image. So here we are trying to find landmarks from a photo. So the number of landmarks are limited, right? So that is why we use something called classification. These landmarks are, you can call them as classes. So wherever you have quantifiable labels or something like that, you can use classification. So suggesting spelling corrections. Any any guess? Oh, okay. So okay, it's gone. Yeah.
That will be sequence prediction.
Okay. Yeah. Can you give the reason for it? Any reason that you think it might be because of
As
that? Like,
because like when we type any word in that, like it gives a related word for that.
okay, sequence prediction. Okay. So the answer for this type of situation is clustering. I'll tell you the reason. So it is very easy to get confused with this particular scenario because sequence prediction is trying to predict the new letter or something. But here we are trying to find a particular mistake in a word. So we are not trying to predict new letter or new word. So we are trying to find out the mistake inside a word. So when you're trying to find a mistake, like if you make a example like advocate, and if you make a mistake in the word called advocate, so the mistake can be like avocate. So this word sounds similar and the letters are similar. So when you use clustering algorithm, you can find exactly where this particular word can be best suited, and you can grab the nearest or closest word to that. So that is where you will be using clustering. Like, did you guys get, did you folks get the meaning of clustering and sequence prediction and why we use it?
Yes, got it.
Okay. Yeah. Okay. So the new example is predicting the quality score of an advertisement. to give a small hint, it is talking more of the range of the answer. So wherever range is involved, there is a particular algorithm that can be used.
Regression?
Yes, it is regression. Can you answer? Like, can you give an explanation for it? Like the reason why you think it is regression?
It is mathematically
Okay.
predicting the
Okay.
forecasting the
Yeah.
result. Yeah.
Yeah. So in this particular, yeah, you told it correctly. So here in our question, we are trying to find a particular value or a number. So a number is something that lies between a particular range. So here we are trying to find the quality score. So when you talk with respect to score or the number, you when you're trying to predict a number or something, you use regression. So for this particular application of ML, we use regression. So estimating arrival time based on type of day and traffic. Okay, this option was auto selected. So anyone want to give any reason why it might be regression? Why it is regression? Estimating arrival time based on time of day and traffic. Based
Because
on the,
we
yeah,
are we are
go on.
telling the time like we are literally estimating like if it is like 1 hour from wherever you are to reach a destination, it
Yes,
takes about 10 minutes further or 10 minutes back of the set time,
yes,
and adjust it to the estimate arrival
yeah,
time whenever
yeah. Correct. So when you take an the example that you have given is correct. So when you take an hour, you have 60 minutes. So 60 minutes is in the range, right? 0 to 100 minutes or 60 or any kind of, it is in a given range. So estimating arrival time. So time here is in a range. So it can be 60 minutes or 100 minutes or even 200 minutes. So that is how you use regression. Wherever something like range exist, you will probably using regression over there. So translating between two languages and sequence prediction. So anybody wants to give answer for that, like why it might be sequence prediction? Okay, so no problem. It is sequence prediction because we are trying to transfer that particular the meaning of a particular sentence to another sentence. So we are trying to transfer that knowledge of one particular data to another data. So here the data that we're transforming is two languages, translating between two languages. So a particular language has a meaning to that sentence. So that same meaning is getting transferred to another type of style that is new language, like like German to French or something like that. So yeah, so that's where we use this. So we are done with our questionnaire, and let's review whatever we have done in the past session and today's session. So first is what is ML. So machine learning is, in simple words, it tries to, the algorithms tries to mimic human intelligence with the help of data. So the more data, it'll learn from the data and the experience and tries to create its own rules internally, like in the form of numbers. So we'll get into in depth about how it is being calculating these numbers and how it's transforming that numbers to our desired output in future sessions. But as of now, it is trying to mimic human intelligence using data and algorithms. And differences between ML and rule based machine learning, it is made on data, and rule based approaches are based on rules itself. So you have to write individual rule for every action to be done, but machine learning models try to learn what to do next, like trying to learn what are the patterns, everything. So you don't need to explicitly code when it comes to ML. You just need to give the data, it'll find the patterns and will give you the output. But for rule based, you need to write down the patterns on detecting that particular output. So when it is rule based is preferable when you have data that can be predicted just based on simple patterns, like simple conditions. But ML can be used in situations like images have diverse range of data, like it might be black or white. You can't write for each and every color or anything, or you cannot write algorithm, like you cannot write conditions for each edge or something like that. So basically, ML is used for complicated uh, problems like where rules cannot be written easily. And anybody wants to talk about idea to implementation? So how is this idea of ML to implementation can be done? What are the steps needs to be taken? So the thing is, in idea to implementation, you have 2 to 3 different blocks in which you need to travel. So the thing is, first you need to have objective. What do you want to create? And next is collecting the data that is required for that particular objective. And after that, you need to create a model on that particular data. And after creating the model, we need to test the model. If the model is not up to the mark, you need to update the model by training it with more data. And even if it is not improving, try to change the objective little bit and try to make it suitable for that particular data. So that is an idea to implementation, like objective, like the what do you plan on doing, then collecting the data set, then training the model, then testing the model, and if it's required, retrain the model or change the objective. So these are the steps. And any differences, like anyone wants to give any differences between AI, ML and DL or deep learning? Okay. So here AI is artificial intelligence. So this is a huge domain which covers ML and DL inside it, but it can even have rule based approaches in it. So any application that tries to be smart and tries to mimic human intelligence, or yeah, human intelligence, so it covers that domain. So AI. And here ML is very specific. ML is towards the algorithms side, where you are using different types of algorithms like these in order to predict the output based on the data. And here deep learning is even more it is a part of ML, and it tries to use different ML algorithms inside it in a layer fashion, and it tries to predict the output. You can think of deep learning as a model containing multiple models inside it. You will get a deeper understanding about ML and DL in future sessions. And as of now, this idea of ML and DL would be sufficient. And types of ML. So we have discussed about classification, clustering, regression, sequence prediction, and style transfer. So classification tries to solve and find the classes with a confidence score attached to it. And clustering is used to find different types of groups inside a cluster. And this is used for any data sets which doesn't have labels. And we have regression. So regression is used to find out a value in a particular range, and this can be with respect to time or prices or distance. So anything which has a numerical value of range like a to b or something, so you can use regression there. For sequence prediction is to find new words or new letters or new data based on the past data. So that is where we use sequence prediction. And the last, style transfer. So style transfer is used to, like we have seen, for filters for images or voice, cloning voice or something like that. So it is to transfer the style. So other word for style transfer is generative. So generative adversarial network, so you can think of it as GANs. So we use style transfer for that. And I right now we are done with different types of machine learning, and now we'll discuss about crowdsource and different types of modules that are present inside Google crowdsource. So Google crowdsource is present inside Android and even on laptops like websites, and it has different types of uh, modules which try to cover majority of what we have discussed, like image label verification, sentiment evaluation, handwritten handwriting recognition, and translation. So we have discussed multiple types of examples, and you can find and you can actually create new data sets by giving your responses. And here you can earn badges and you can level up based on your contribution to the Google crowdsource. So this would be more of volunteering effort, and this would place you in a leaderboard with other contributors around the world, and you can connect with other contributors, and based on your level you get promoted in Facebook and different social media networks. And this will help Google products for good in detecting and making Google services more efficient. So you by doing this you will be part of the movement which tries to bring good for the models, and by making a huge difference by contributing to Google crowdsource.
Thank you so much.